Hi everyone, my name is Kun Zhang, and I'm going to introduce my final project of pattern recognition. My project title is Traffic Sign Recognitions based on deep learning. So this is my content. I will introduce the following parts: introduction, problems and approaches, performance and evaluation. The last one is conclusion. So let me start from the introduction. We can see there are many accidents in US in recent years. In response to the traffic safety programs, many solutions are under researching. One of these solutions is Advanced Driver Assistance System, ADAS, and Automatic Traffic Sign Detection and Recognition, TSDR, is an important part of ADAS. But there are many problems in recognizing correct the traffic signs in the natural environment, like light condition and motion blur. I will introduce later. In my project, I implement some methods to fix these problems. So let me introduce the problems under studying and the correlated approaches in detail. First, influence of light conditions is a big problem. They are dependent on different times of day and weather. The traffic signs images under bad light condition are hard to be recognized. We can see from this figure, A is obviously underexposed, while B is overexposed, and C was taken under poor weather conditions, such as foggy weather. The second problem is faded or damaged signs. Due to disrepair or man-made damage, the signs may be discolored or deformed. In such case, the lack of color information and shape information will lead to low recognition accuracy of traffic signs. And the third one is motion blur. When the vehicle-mounted camera shoots the road surface during high-speed driving, it is likely to cause motion blur of the captured image, which is difficult to recognize. This figure shows the images with motion blur. We can hardly recognize them even by naked eyes. As for the traffic signs blocked partially, it's in the actual road environment. It is easy to find that some traffic signs are partially blocked, such as trees on the roadside, telephone poles, or other signs. Besides, there is another problem about the data I use in this project: unbalanced distribution of traffic sign types. The category distribution is uneven because the data used in this project is from German traffic signs, which has 43 types of signs, but different numbers of each type. So in order to solve these problems, my corresponding approaches are implemented. The first one is image clipping. Although there is only one traffic sign image in each image of the dataset, it still has 10% of the background edges, which is useless in this project. Thus, image clipping to extract region of traffic signs is a necessary approach in pre-processing. We can see from this figure, A and C are the images before clipping. B and D are the images after clipping. which reduce the noise in the images and the pixels of data I need to deal with. The second approach is image enhancement. Image enhancement is mainly process of performing certain processing on the original image for specific applications. I use two specific methods of image enhancement in my project. One is direct grayscale transformation. The other one is histogram equalization. As for in the grayscale transformation, it refers to the method of changing the grayscale value of each pixel in the source image, the point by point, according to a certain transformation condition. It is to improve the picture quality and make the image display clearly. Direct grayscale transformation is based on the equation below, S equal to C gamma degree. This figure shows the different results of image transformation when gamma takes different values. As well, histogram equalization. It is a computer image processing technique used to improve contrast in images by effectively spreading out the most frequent intensity values. We can see from this figure, A is the original image, B is the image after histogram equalization process, C is the histogram of original image, D is the image after process. So it is obvious B can perform well after processing. Data augmentation is also implemented to solve the problem of unbalanced data types. It is mainly to increase the size of the training set and adjust the category distribution. This project mainly makes good use of three ways to transform the space of images: rotating, movement, and scaling transformation. At last, a fine transformation would be implemented to create more images. This figure shows the as we can see, the number of every type become 4,000 after data augmentation. So the last approach is enhance the strategy of CNN based on the results of tests by using classic CNN and change of some parameters. The improvement of the CNN network model is mainly enhanced by following aspects. First, introducing batch normalization, regularization after the polling layer to process dataset. The second is to use the job out layer after normalizing the batch normalization of the polling layer. Then at last, changing the number of channels in the convolution layers. This figure shows the structure of enhanced CNN networks. You can see these three batch normalization at the polling layers, and there are three job out. Okay, after implementing the approaches, what the performance would be. First, we can see so let's select the best optimization algorithm. There are commonly used optimization algorithm like SGD, momentum, add grade, add data, and add the results of trying these 5 different optimizers in the enhanced CNN model in this project are shown below. We can find SGD momentum and at grade have shorter chaining time, but accuracy is low. At delta has long chaining time and the accuracy is not high. So I choose the moderate one, Adam. This one, its performance well in the of these types. And as for dropout parameter, this parameter represents the rate of retention of a layer that have been activated after passing through the dropout layer. When the number of neurons is large, the parameter is small, it may cause underfitting. The larger parameter may not produce enough dropout to prevent overfitting. So we can see from this figure, 0.8 is the best one. As for the influence of pre-processing, different pre-processing will affect the final recognition accuracy rate. So special attention should be paid to this program when pre-processing the training data and the test set. When the creep limit parameter is 40, although the training time and the recognition time are relatively high, but the recognition accuracy rate has also been greatly improved. So I will choose the 40 in my project. So at last we can see the results of the project. The final parameters of the enhanced CNN model used in this project are initialization method. I choose the normal optimizer. I choose Adam. As well, learning rate 0.001. Dropout parameter, I choose 0.8, I mentioned above. And the processing parameter of the dataset I used is 40. So we can see the epochs is 10. And the last training accuracy is 99.02%. So the conclusion in pre-processing. Pre-processing is really important before dealing with the datasets of images. In this way, the problems like influence of bad light condition, traffic signs block the partially are fixed. It increased the speed of training and the accuracy of tests. In the CNN networks, based on the papers related to CNN networks, it is easy to find that more complicated CNN network does not mean better performance. By designing proper structure and setting good parameters, the CNN networks can get a great model that owns great accuracy of testing and fast running speed. So that's all. Thank you.